Hi guys, hope you're doing well. Welcome back to the channel. This is a follow-on video really from the conversion of this OX CNC router to USB. Now you may have seen in that previous video, and I'll put a link up to it, how I converted this from the old parallel port to USB. Now you may have seen this thing about, and I said I was going to keep that for another video because I didn't want to make it too long. So this was the impetus for me to get the CNC router going again, to get this needle cutter working. And what it does, and you'll see later in the video how we do this, we can cut out foam board parts. And this is some parts for my my MiG-29, which I've crashed. Repaired it a few times, but it's a little bit beyond it this time. So, and there's quite a lot of foam board jets around now. The one that's really sparked my interest again in building some more foam boards is JetWorks Online. They do some amazing jets, and they also use a lot of 3D printed parts as well. So that's, I mean, as you're probably aware, 3D printing is really coming into the RC hobby now. And just over there where the foam cutter sits, there's I've just 3D printed one of the Eclipse-on planes, the Model A, on the Creality CR10 V2 here. So I've got quite a few things going off at the moment. So what we're going to cover in this video, I'm going to try and keep it a bit shorter than normal videos. So basically I'm just going to cover the setup of the needle cutter and then show you how it works. I'm not going to go in this video into how the files are created to put on the needle cutter. There are quite a few videos on YouTube about that already. So what I'm going to probably do is link you to them. If there's enough interest on how to create the files, they're basically DXF files. If there's enough interest and people want to know how to create them DXF files, I'll do a separate video on that. So what we're going to cover in this video is the setup, what you need for it, and then we'll go in and show you how it actually works. And to be honest guys, I'm quite impressed with it. So if that sounds interesting, you guys, stick around for the next part and I'll discuss how it works. So I was looking into using a laser cutter, but when I started investigating it, the thing with a laser cutter, it doesn't work very well on white Depron. It's something to do with the wavelength. It just reflects it. It doesn't cut very well. And I was looking at like the diode laser cutters, which are sort of a reasonable price. Now you can do foam with laser cutters, but I think you have to start going into CO2 laser cutters, and that's a whole new ball game, you know. And I haven't got a great deal of space, as you may see here. Wife complains I fill too much of it up anyway, but never mind. So I looked at the needle cutter. I also looked at a drag knife as well, and there's a few 3D printed drag knives that are on Thingiverse. They look quite interesting as well, but I've been really impressed with this. I was a bit uncertain about it to start with, but looking at the cuts that are coming out now, the cuts are absolutely brilliant. So guys, in this section what I'm going to do is explain to you the various parts on this needle cutter. Now on the USB conversion video I had the open builds mount there. That's upside down actually, that way. So I had the open builds mount there, and then to start with I had the palm router in there. These are brilliant, these are. This is a Katsu one. I think it was only about 40 odd pound UK, so it works really well. And then what we did as well, just to prove it all worked, rather than getting the router going and creating lots of dust, we attached the pen holder to it. And you may have seen, and I'll put a picture up, you may have seen the pen holder working in creating that little RC keys. So all I've done is I've removed the mounts there, and this is the needle cutter. So basically what we've got, this is 3D printed, and there's quite a few of these on Thingiverse, and the main guy that's behind most of this is a well, there's a few actually, but the guy that sort of sparked my interest in it is a guy called EdwardRC. His system's a little bit different. He uses 2 linear rails, and it's a lot bigger than this. So I might do that later as well, if it, if I get into building lots more of these. But it's basically, this part here is basically the same. So I've adapted this slightly to fit onto the OX mount there, and then all we've got really, let me just move that out of the way. We use a very thin wire, and this wire here is I think it's 0.6mm in diameter. I think it's actually called jewellery wire, I think, but it's a stainless steel wire. And then what we've got there is a welding tip from a MIG welder. So, and all that happens is that wire just goes through there, and that's what you can see there. So we've got the welding tip there. That's just a mount there for the welding tip. There's a nut on the inside, and all that happens, if you can see that, as the motor goes round, it goes up and down and creates a needle cutter. Basically a sewing machine. And to control it, we've got a standard speed controller here. So that one there I've got is an old one I've used many times before. I think that's a 25 amp speed controller, but it doesn't need anything like that. And then what we've got here is let me just take that off there for you. I've just got it rigged up at the moment because I've just started using it, but I will get it rigged up to use more permanent. And then we just got a standard servo tester there which controls the speed controller. And for power, what I've done is you could just connect a LiPo battery into this, a 3S LiPo battery. But what I've done, I've actually wired it back, and on the, I think you can just see it there, on the board there, that's a 12 volt power supply, that's a 5 amp. And I have measured the current going to the needle cutter while it's been running, and it's barely pulling an amp. So because there's no real load on it, it's not like there's a propeller on there and it's pulling. And I think this is a 2212. I'll put the details up, but all the details of this and how to build it are on EdwardRC's channel. So I'll link you to that as well, rather than me doing it again. So it's 3D printed. It's got some bearings there just to guide the wire, and the wire goes through the bottom there, and that's basically how it works. Now the only thing you have to do is to get the speed of the motor, and you'll see me doing that when we're doing testing. And all we'll use for that is where did I put it? So all we use for that is one of these tachometer testers, and it's just got I've just got a black line on there, so I put it up to there, and they reckon the ideal speed is about 8,500 RPM. So we just get that running, and it's not very far up on the needle on the servo tester. And so far, I've done some test cuts, and I've cut out, as you'll see later, because I'm actually filming the intro after we've done the test cuts. As you'll see later, I've cut out all these parts, and I've done some test cuts as well, and it works fairly well. What I've done as well is I've put this foam on top of the MDF board there on the CNC machine, because the needle cutter does actually go, I think it actually travels 9mm, I think. So it's actually going through the foam. Apparently you can do it as a score cut, and in the CAM software, basically it's treated basically like a laser cutter. So all the settings you use for a laser cutter work exactly the same on here. Like curve value and obviously power doesn't, because the power doesn't matter. So you set that there. So that's all you're going to need really. And if anyone's interested and they want this mount for the OX CNC, just let me know, and I can put that up on Thingiverse. It's based on one that's very similar. There's a lot of guys use a system called MP CNC, mostly printed CNC, and it has a similar type of mount to that, but it's these edges are angled more to fit, but this fits perfectly on the OX, and it's got some T-nuts in there that hold it on. So So that's it basically, guys. And as you can see, we'll see from the testing, it works really well. I'm really impressed with it. So yeah, if you want to build one, I'll probably put a posting on the website as well with all the details of the parts. And but that's another good use for my CNC router. So what we'll do now is I'll go on and show you how we actually test it. And as I said, if you're interested in how to generate the DXF files, let me know. And if there's enough interest, I'll do a video on it. But there are quite a few videos on YouTube already. A lot of guys use Inkscape, and I think EdwardRC has actually a plugin for Inkscape, but I don't think it'd work particularly well on here. Basically, what I've done is I've used some conversion programs and Fusion 360. So if anyone interested, I'll do that as a separate video. So I've only got it temporarily set up at the moment. Once it proves to be okay, then probably what I'll do is I'll 3D print a mount for the speed controller and the servo tester there to get them right. So what I've done is I've pre-cut a piece of foam, and on the actual CNC machine, I've put some board here. This is just some white polystyrene board I had from some packaging, or was some time ago. And because what will happen is the needle cutter does actually go slightly through the Depron 6mm. So underneath here there's some MDF, so we don't want it hitting into that. It'll probably damage the needle. So this here is double-sided taped onto the board, and you can see it's not very thick, so and there's plenty of room under here. So all we need to do is position the Depron board onto the machine, and then get it zeroed in and set it going. So what we'll do first of all then is I'll open the file up, and I'm using the OpenBuild's control software. Let's go into OpenBuild's control. Sorry, not OpenBuild's, the OpenBuild's CAM. So this is the file we've got here. So I've been testing this earlier, and I have done a previous cut on it, and it's worked okay on some scrap foam. So this was a test I did earlier, the cutout part, and I'll show you the. And here's the part that came out. So it came out quite well. I'll start with a new empty workspace, and then we'll go into File, Open Drawing, and then Sheet 1. So that's what we're going to be cutting. Now, the way this is set up is we use it like a laser cutter, because effectively that's basically what it is. It's very similar to a laser cutter. So what we're going to do first of all is we're going to go and select the servo hole there. So if we just click on it, it should show us which one it's. Yeah, there we are. So polyline 01, so that's the servo hole. So that wants to be an inside cut. So what we do is we go add down here, create new operation, and then it brings up this dialog box here, and we can go select operation, and then we're going to do laser vector path inside. And if we scroll down, I've already got the curve value set at 0.6, which is the thickness of that little wire. And then I've been experimenting with the feed rate, and to start with I found it was a little bit too fast, so I've dropped it down to 600 millimeters per minute, which might actually be a little bit on the slow side, but it seems to work okay so far. So perhaps later on when I've got some more time I might test just upping the speed a little bit, but it's not as like I've got a lot to do anyway. So we'll do that one. So that's the first thing we're going to do. So then what we can do then, we can go in and then cut the fin section. So if we expand that out, so I'll see which one it is it that one? No, that's the tail, so we'll do the fin. There we go. We could actually do these both at once, but we'll do them separately. So we go, and then we want to take the polyline off, because we've already done that one. So we do add, create new operation, select the type of cut. Now this is going to be a laser path outside, so we go around the outside of the part, and then the other settings are the same as we had before, so we can say OK to that. And then what we're going to do then, we'll take that one off, and then we'll go, which is now the elevator, and we go to add one. The old computer is struggling a little bit. That's why it's you can hear the fan kicking in. So we do add, create new operation, and this is going to be an outside cut again. Where are we? Laser vector path outside, and apply that. So we've now got all them selected, and we can tell it to generate the G code. Now at the moment I haven't got the Open Builds control software running, so we'll just minimize that. And what it will do, it'll automatically put the G code in there. Right, so we've got that. And what we'll do is we'll connect. And the first thing I'm going to do is I'm going to just put the needle up so it doesn't catch on anything. And then I'm going to set it to home it. Right, so we've got that on now. So go back to the control software, and you can see now we've got this here, transfer G code to Open Builds control. So we'll do that. And now we've got the G code in there. Now before we can do anything, what we need to do is we need to get the foam. Now this piece of foam is, so this piece of foam here is the maximum cutting area I've got on this machine. So it's not a great deal. I think it's 315 by 520, but it's enough to get these two parts out. So what we can do first of all, just to make sure everything's okay, we can do something called check size, and that will tell us where it's going to come to on the foam. Make sure we've got it sort of in the right place. So if we just do check size, and if we've got any errors, it will tell us. So we'll do check size. So that's the map. Yeah, so we've got quite a bit more on the end. Yeah, so that's not looking too bad there. So what I'm going to do now is we'll get it set up ready for the cut in the next section. So what we need to do now, guys, is get the foam positioned and get the needle cutter set up as well. So what I tend to do is make sure the needle's right up so it's not piercing. I don't know whether you can see that there, but the needle's out there. So just turn it up to the top, and then what I do then, I'll get me T out of the way. So what we'll do is we'll bring the Z down. Right, that's pretty close there on 10mm increments. So I'll go to 1mm. Let's put my T out of the way. And then what I like to do is get some paper, Right, and then keep bringing it down until we get pretty close. Come off it there. Down. Right, that's dragging a bit now, so we'll go to 0.1. Just come back up. Yeah, I tend to get it fairly loose because the actual cut goes through anyway. So what I want to do now, so that's at 0. So we'll put it about there. Well, we'll put it near the front. And then to keep the foam in place, what I found works quite well is just masking tape. So we'll use some masking tape. All I'll do is get it on the edge there. Now what we want to do now is check the speed of the brushless motor. Now to do that, what I've got is one of these tachometers. I've had it quite a few years. I originally bought it for when I was tuning nitro engines, but it works quite well. So I've got the servo tester up there, and I have marked it where the speed is about right. So what I'll do is I'll switch it on now. It'll get quite noisy now. If I test it, well, you can probably won't be able to see it very well. But what we want is about 8,500 RPM. Yeah, it's a bit hit and miss, but that's near. So that's going the correct speed now. So all we do now, all being well, is run the G code. There we go. So now we're doing the outside. There we are, finished. Right. What I'll do is I'll get you in for a better look at this. So don't know whether you can see that with it being white, but you can see the lines there that have been cut out, and I think the parts will just pop out, I think. Yeah. Piece of tape there. There we go. Piece of tape there. There we go. There's the cutout section. And here's the elevator. So I'll just show you. I've probably shown you this section before in the video, but here's the MiG-29 that suffered a bit of a failure. I was going to rebuild it, and I had cut it off there. The other bits of it are here, so you can. She suffered a bit of a nosedive, and so that was a good test for this needle cutter, because I've also been looking at a lot of the Jetworks online jets as well. But I thought this would be a good test. This has been repaired a few times, and I thought it's just got a little bit beyond it. So what I'm going to do as well, on the foam cutter, I'm going to cut out this thicker section here. I've got some more XPS foam. Now, as you can see, this isn't going to fit on the foam cutter. So what I'm going to do in the files, I'm actually going to make this as 2 parts so we can get it all on the foam cutter. But so that's the test cut. So what I'll do is I'll cut all the rest of the parts out, and I'll show you the parts at the end. So guys, that brings us to the end of this video, a bit shorter than my normal videos. So I'm trying to make them shorter if possible and break them into smaller videos. So that's a needle cutter. Now, if you are needing any help, a great source of help, and it really helped me out, was on Facebook. Now, I'm not a big Facebook user, being an old man. You know, but one of the things I found really useful on Facebook is Facebook groups, and I've joined the couple of groups. So JetWorks Online for all the foam board planes with 3D printed parts, and there's some awesome stuff on there, guys. I'll put a link up. I encourage you to have a look on there. The guys behind that are amazing. And the other group that I've joined is the one for the needle cutter. I think it's, and I'll put links up for them as well. Now, when I was building this, there's some tiny little bearings here which I managed to get hold of, but then there's some tiny little washers that go to stop the bearings binding on the 3D printed parts, and I was really struggling to get hold of them. So I put a post in on the Facebook group, and I'll put the guy's name up. I can't remember it at the moment, but I'll put the guy's name up. And I said to him, "Does anyone know where you get these from?" And the guy said to me, "Well, send me your address and I'll send you some." And true to his word, I mean, I offered to pay for them, and he didn't want any payment for them. So thank you very much. And you know, that is one of the benefits of groups. You know, Facebook can be a bit of a nightmare for you know, as you well may know. But I think there are some useful parts to it, like any of the internet. So yeah, do join that group, because there's some good stuff on there, and some guys that will help you out if you do get into trouble. They certainly helped me out. So that brings us to the end of the video. I hope it's been interesting. Again, if you want me to show you how to create the DXF files, if I get enough interest, then I will do that. But it could be a longish video, so I don't want to spend a lot of time making a video and it's of not much interest to people, where there's already videos that on the internet anyway how to do that. A lot of guys use Inkscape for that as well. So thanks very much for watching, and I'll catch you in the next one, guys.